Welcome to BSc Statistics students. In this lesson, I discuss additive property of geometric distribution. What is the additive property? If you consider n independent geometric variates, if you consider the sum of the n independent geometric variates, then it becomes a negative binomial variate. Only the additive property of geometric distribution will be differ from the remaining all additive properties of any distributions. Additive property of any other distributions. So therefore, here if you consider Poisson distribution, additive property of Poisson distribution, sum of n independent Poisson variates is again a Poisson variate, normal distribution, again a normal distribution like that. But geometric distribution, as per the geometric distribution is concerned, sum of n independent geometric variates is a negative binomial variate. That is the statement of the additive property. If you prove this, let us consider x1, x2 and so on xn are n independent geometric variates, which means follows a geometric distribution, which means I consider the moment generating function mx1t. So what is mxt? Mxt of the geometric distribution is p divided by 1 minus q e power t. If you write this one in the denominator, in the numerator, p into 1 minus q e power t the whole power minus 1. This is what the additive property, that is moment generating function of geometric distribution. Now, if you consider the same moment generating function for all the mx1t, mx2t and so on, then for the variable x1, the moment generating function p into 1 minus q e power t the whole power minus 1. For example, for the variable x2, mx2t is equal to p into 1 minus q e power t the whole power minus 1, because they are all independent and so on. For example, you consider moment generating function of n xn, that is also p into 1 minus q e power t the whole power minus 1. This is what the moment generating function I have written for all the x1, x2 and so on xn. Now you have to consider the moment generating function of sum of the n independent random variables, that is summation xi. So if you consider moment generating function of summation I is equal to 1 to n xi, it is equivalent to be, it can be written as the moment generating function of individual, that is mx1 plus x2 plus and so on plus xnt can be expressed as is equivalent to be mx1t into mx2t multiplied by and so on multiplied by mxnt. And we know mx1t, mx2t, mxnt. So therefore it is equivalent to be, if you write mx1t is p into 1 minus q e power t the whole power minus 1 multiplied by mx2t again p into 1 minus q e power t the whole power minus 1 multiplied by and so on multiplied by 1 minus p multiplied by p into 1 minus q e power t the whole power minus 1. If you see, now we combine, how many p's are there? 1 p into p and so on. How many? N p's are there. Hence it is p power n into 1 minus, how many 1 minus q e power t's are there? Again n, that is minus n. Then if you consider this is, if you write it in the form of the moment generating function of negative binomial distribution, p divided by 1 minus q e power t the whole power minus n, whole power n plus n, because it is minus n, therefore you can consider this in the denominator. Here we have denominator whole power n, so therefore p divided by 1 minus q power t whole power n. Therefore this is looking to be a moment generating function of negative binomial distribution. So therefore this is if this is negative binomial distribution MGF, then by the uniqueness theorem of moment generating function, if the two particular moment generating functions are equal, then their distributions are equal, right? So if you by the property of the additive property of moment generating function, we have calculated this and the moment generating function of summation xi, which is equivalent to be moment generating function of negative binomial distribution. That is, if you consider x1, x2, and so on, xn are geometric distribution variables, variables of the geometric distribution, then summation xi, if you add x1 plus x2 plus and so on xn, the variable, then summation xi, which becomes a negative binomial distribution with the parameters here n and p, the parameters n and p. If you understand, this is what the additive property of the geometric distribution. If you consider an independent geometric variates, and if you consider the sum of the unindependent geometric variates, it becomes a negative binomial variate, and with the parameters n and small p. Small p is probability of success, and n is number of trials. Thank you so much.